An effort for cloud standards and interoperability. So this is a Government of India kind of initiative, and I'm participating in this from an organization called CCICI, which stands for the Cloud Computing Innovation Council of India, and we are involved in this, and definitely would. If you find this talk interesting, we'd be very happy if some of you would be interested in being involved as well. So I'm going to cover three things over here. Essentially, the talk will be divided into three parts. So first is why interoperability. Then the second is what is happening now in the rest of the world on interoperability efforts in cloud, including, of course, storage, which is one of the things that we're looking at. And the third thing is what is it that we are doing. So this is what I'll cover in brief. So first of all, let us talk about why interoperability. I mean, I know interoperability is a nice thing to have, but that's not what I want to talk about. Why is it really important to have? I think. So first, a couple of cartoons over here. People may not necessarily be able to agree on what is interoperability. So that's the first thing. And the second thing is, of course, as you all know, we have a lot of different cloud vendors. And interoperability has not been necessarily the top priority for most of the vendors, who are, of course, more interested in adding important features. And so, therefore, we do find that cloud vendors, the current state is that interoperability is not very high, and porting applications or getting applications to talk to one another could be very difficult. So anyway, jokes apart, why really do we need it? So as you can see, government is fueling the adoption of cloud. There are a lot of government services that are moving to the cloud. For example, if I take a look at it, so we have an initiative called Meghraj, and what that does is that would have different clouds in different states, as a national cloud, and so on and so forth. So now it's quite likely that the different clouds would want to have exchange information. There could be applications that want to draw information from, say, a state cloud, and then another application that you want to draw information from a national cloud. So if these are not interoperable, then that will be very difficult, because there will be a lot of barriers to making this happen, and that will not be a smooth and simple process. But even within, so this situation arises because, of course, the government has empaneled, I think, something like 13 or 17 cloud service providers who can provide service to the government. And of course, the different entities in the government, such as the different states, the different departments, they would all use, in general, they would use different cloud service providers. And so then the question arises, how can they all share information and work together? But again, even within a state, as you can see, there are a lot of applications which we may want to work together. For example, if you take a scenario like a smart city scenario, there could be garbage information which is in the waste management kind of a thing, in the waste management databases that are available. And in terms of pollution information, there could be healthcare data which talks about where different diseases are. In the water management thing, you may have information on where there are lakes or standing amounts of water, and so on and so forth. So from all of these things, it would be desirable to integrate all this information together, so you can talk about, for example, what is the impact on health of garbage, or where are the critical pieces of garbage that need to be removed for better health. Similarly, if you take a look at Aadhaar, it has a very important role in the sense that it can identify a person, and therefore, if one wants to, for some legitimate purposes, link records together, it can provide a useful linkage kind of a mechanism. But again, in general, the data we want to link may be at different parts in the cloud. For example, people may want to have a medical database, and in the medical database, when you link records together, there has to be 100% accuracy, because if you accidentally, say, match part of my medical history with the medical history of somebody who has the same or similar name, you can have very serious errors that take place in that case. So in the case of, there are some cases like medical history where you need to have 100% accuracy in matching, and Aadhaar is one of the things that can do that. And again, in general, these things may be available in different databases, in different clouds. So how can we have that happen? And again, nowadays, there's a lot of talk about personalized medicine and so on and so forth. So this would require the use of large patient databases, because you cannot do the traditional triple blind testing with different DNA variations and so on to come up with these things. So in this case, some sort of patient database which is reasonably large and spans a lot of people over a large period of time is required. So for all of these things, interoperability is not just nice to have thing, okay, I'd love to have it if it's there, but if it isn't there, I don't care. It's really something that's quite essential. The second thing, of course, the India perspective thing. So this is a chart on the left-hand side which shows the population of various countries. So if you take a look at the yellow part over here, that is China, and then this is India, and this is the next biggest country, which is the US, and our neighbors are over here. So you can see that comparative, I think I like this chart because it shows visually how huge we are compared to everybody else. And since we are so huge compared to everybody else, we definitely need a technology which is capable of scaling, which is the cloud. And so we don't have a choice other than to embrace cloud technology for many of these services. The third thing, of course, is that this is an opportunity for us to leapfrog in technology. If you take a look at, in many cases, we have already adapted a more advanced technology instead of following the technology evolution in Western countries. For example, we have most of our internet users are people who are using smartphones. This is not the case in the Western countries or developed countries. Then also, there are some very interesting papers, for example, by Microsoft Research, which talk about how people use smartphones and how this is not confined only to the rich. For example, if you take a look at migrant laborers, they don't, of course, have TVs in the places where they stay. So apparently, one of the things which is reasonably common is that they have a smartphone, and using the internet connection, they download movies and other shows that they want to watch during the day, and in night time when they're free, they watch it. Similarly, similar paper also by Microsoft Research shows that if you look at these users, they're semi-literate, so they're not that comfortable with a text interface. So they use a voice interface, and voice interfaces are, of course, computationally much more much more compute intensive. They require much more resources than a text interface. And in fact, if you think about it, things like Alexa and so on and so forth, they're actually more useful in India than they would be in the West, because of a large population of semi-literate users. And so something like Alexa really would be much more useful for us. But anyway, the point I'm trying to make is the use of all these advanced technologies requires us to use the cloud. And so we find ourselves in the position that in order to get the maximum benefit of this technology, we are in the position that we have to use the most advanced technology that is there, advanced in the sense of recent and state-of-the-art, rather than older technology, which used to be the case in the past. So for these reasons, interoperability is absolutely necessary, and we need to embrace the cloud, and in the cloud, we need to have interoperability. So this is the task force that we are working on. So the government of India has a body called the Telecom Standards, TSDSI, which stands for the Telecom Standards Development something of India. So this is a body that has been promoted by the Department of Telecommunications. This is a private and public body. So the governing board has some members from the government, and it has, so essentially companies such as Reliance or academic institutions also like IIT Bombay and so on, they pay an annual fee. And when they pay an annual fee, they become members of this body. And as members of this body, the body has a number of working groups. And each working group takes up some item for study. So, for example, one of the working group items taken up is how do you standardize for I forget what the name of the standard is, but for this emergency response in cities. If you have, if you're in a city and there is emergency occurs and you have walkie-talkies and other emergency equipment used by people, then what is the standards that is needed, standards in terms of deployment infrastructure, standards in terms of wireless protocols, standards, those kind of standards, what is really needed in order to do that. So that's an example of a work item which TSDSI takes up. So they formulate the work item and then that is passed on to DoT as a standard, and then DoT goes ahead and ratifies it as a standard. So one of the things that the Department of Telecommunications also wanted to do was this problem of interoperability between clouds, because as I mentioned, the government wants to have a big push in cloud technology by making many services cloud enabled. And also, obviously, the government does not want to be locked into any one vendor. And as I said, the government also wants to make sure that if different government agencies pick up different cloud vendors, which you need to do in order to make sure there's no monopoly, these can all talk to each other. So they set up a working group in order to provide standards for cloud in India. So then the TSDSI came and approached our organization, which is the Cloud Computing Innovation Council of India. So this is a non-profit society. It's essentially, we have two kinds of members, institutional members like Microsoft, IBM, and so on and so forth. And we also have individual members. So this is a non-profit society with members drawn both from academia like myself, government, and also industrial bodies. And so the idea is to foster the growth of cloud computing. So we had some important initiatives so far. So one of them is the production of a white paper laying out a strategy for cloud in India. Then we have worked with government in a couple of cases as an advisory role on their RFPs and those kind of things. And also we have participated in, for example, the Ministry of Information Technologies study on the usage of cloud in India and how it should work in forward. And of course, the other thing we are working on is the interoperability effort that I'm talking about today. So please feel free to ask questions at any time. So let me talk about, let me move on to the next part of my talk, which is what's currently happening in the area of interoperability in the rest of the world. So we've identified two which seem to be important and seem to have a lot of traction. One is the ISO effort, and the other is IEEE NIST. NIST is the National Institute for Standards and Technology in the United States, a joint effort by them to develop a set of cloud standards. I'll just review these. Okay. So the ISO IEC, the cloud standard, is called IEC 19941. So it's not exactly a standard in the way we understand a standard to be. So the goal was, as I said, early on we don't have a definition of what's interoperability. So the aim of the IEC standard is to define what is interoperability. So they have tried to do this by talking about a common vocabulary, and then the approach they've used is to define a facet model. So they have a facet, according to them, interoperability has three facets. So one facet is interoperability between the clouds themselves. The second facet is interoperability between the different cloud applications. And the third facet is portability of data across clouds. So I give an example of this by talking about the cloud data portability facet. So this is the cloud data portability facet. Summary of it as given in the standard. So they had the in the facet they've got three parts to it. So the first part is the syntactic part. So the idea is that in the syntax, so there's a syntactic requirement that the two sides which are exchanging data, there should be a common format for the data to be exchanged, and of course it should be a machine readable format. So examples given are XML, CSV, and JSON. So the thing about the ISO IEC 19941 standard is that it doesn't actually mandate something. What it really says is that you need to have a well-defined format for the clouds to interact with data. And the examples they give of such formats are XML, CSV, and JSON. So they're not standardized on anything. It's like this is what we need, and these are examples of what we need. The second one is semantic informational data, and that has to do with what does the data really mean. And this can be done through ontologies or data schemas and so on. And the examples they're given are OWL and the Dublin core schema. And then the third one is a data policy thing, which is how do you in the system specify the regulatory and organizational policies. So for example, that certain data can be, so there could be security policies such as certain data can be accessed only by certain people. There could be availability policies which says that this data has to be replicated at least 3 times. There could be other policies saying that the data has to be snapshotted once a week. So how can you specify all these policies? So they have talked about, I don't know if there are too many standards in this area, but they have identified this as being a requirement which they need. So this is the highlights of the IEC 19941. And as you can see, it's more about defining what is interoperability and what are some current standards that support interoperability rather than being a standard like, say, TCP/IP, which specifies what is the header format and those kind of things. Yes. Sorry, could you please repeat that? Okay, so are you talking about things like GDSPR and so on? Yeah, so right now I think those are kind of hard-coded into systems. I don't think there is policy language which specifies that this is the way it is to be done and so on. Was that your question? Maybe you can take it offline if that's not exactly the question. Yeah.
The guidelines.
So vendors are participating in this, but this is a fairly broad exercise which doesn't mandate anything. So some vendors are complying to some parts of it, and some vendors are not. So this is kind of like a very broad guideline kind of a thing. It's not, there's no mandate, for example, that everybody has to, there's no mandate to say that for data semantic, we have to use OWL, and everybody should support OWL. It's not like that. So this is just a set of guidelines which is good to have. And the purpose is to define what is needed for interoperability. So what is needed for interoperability, for example, is that there should be some syntax by which they can give data, and examples are given. So the second major effort that is there is the IEEE NIST P2302. So this has actually gone through 2 phases. Initially it was just an IEEE effort, And now it has been joined by NIST, which is the National Institute of Standards and Technology, and so therefore it's got more traction. So here the idea is to create a transparent, this is still work in progress, so we don't have a complete set of standards on this. But in our working group, we have kind of informally thought that since this is likely to emerge as an important standard, probably whatever we do should be able to easily migrate to this relatively when the standard becomes defined. So here the objective is to create a transparent cloud provider ecosystem. So again, over here, we can see that there is a difference in approach between these two. So if you take a look at ISO, it's looking at it from a kind of cloud perspective and saying what must a cloud have in order to be interoperable. Whereas IEEE P2302 is saying what is the ecosystem I need? If I've got multiple clouds, what is the ecosystem that has? So in a way, it's the same thing, but IEEE is looking at the ecosystem first and then defining what is needed, as opposed to looking at an individual cloud and saying, if I want to interoperate with somebody else, what do I need? So then the other thing about the IEEE P2302 is that they want to have a dynamic infrastructure, and in addition to technical issues, they also want to be able to address issues like audit, billing, and so on and so forth. So probably the best way to understand the IEEE 2302 thing is to take a look at some typical kind of flow that may occur. So you can see over here that there's a user in cloud A. So actually, so this cloud A is in a regulatory domain A. So that could be, say, India, for example, could be a regulatory domain, and it's in an administrative domain A. So administrative domain could be a cloud, or it could be maybe an enterprise like TSDSI cloud or something like that. And inside that there is a user A, and he wants to get some resource. So first thing he does is he sends a request to the federation broker, which is the green column next to the user. Okay, so the federation broker maintains a list of all the resources that are available across all the different clouds. And what the user would get a response from the federation broker. Of course, as you can see, there are security and authentication pieces all along, which I have not mentioned. And from the request the federation broker, he would get back a list of resources which are available in different clouds. And this could be his own cloud as well. It doesn't have to be necessarily a remote cloud. So it's kind of transparent. You're getting resources from the federation. And then having done that, once you have that, so because you supply your security credentials, you'll only get a list of resources that you have access to. So in that case, you can just go to the remote cloud, which is regulatory environment B over there, and then you could request those resources. So that's the idea. It's kind of transparent, and it's sort of similar to the way that if you have a cell phone and you're an Airtel user, for example, and you go and make a request for somebody you want to call somebody who's a Reliance user, then Airtel will simply pass the call along. So that's kind of the model, and this is called by them cloud to cloud federation. They have another variation called user to cloud federation, which is kind of different. That is like you would have separate security tokens for different clouds, and you would contact the cloud you need. That is sort of analogous to saying that if I want to call somebody in Reliance, I need to have a Reliance SIM. If I want to call somebody in some other network, I need to have a SIM for that. So this is probably the more desirable one, which they call cloud to cloud federation. And so they have different deployment models. So the one we kind of showed is probably this one, the centralized trusted third party, where there is a number of clouds which are all connected to one federation broker. But you can also have peer-to-peer, simple pairwise federation, whereby the federation broker is distributed across multiple clouds. So these are the different varieties of federation that they intend to support. So the summary of the state is that currently there's no interoperability standard which fits the need, but there are proprietary solutions. So let me move on to our work. So this is our approach. And what our approach is, first of all, our approach is kind of different from the what I have the impression as of many other approaches, which is that of trying to figure out what are the standards needed, or trying to figure out what is the functionality needed in a global sense, and then trying to build a standard for that. We want it to be a lean standard. So what we said is, instead of doing that, we are going to take a look at specific use cases that we want to support. So what are our priorities in India? We want to support smart cities. Then another important use case is, suppose I've got a legacy data center which wants to interface with something in the cloud. How does it do that? So these are specific cases that we are taking up. We are going to build a standard, a minimal standard, which satisfies all these use cases. We are not going to go for a very large standard which can take care of current users as well as future users. So our first step is to define the use cases we need. And the second step is to look at the existing standards and see, do those already support the use cases that we want to do. If not, then we found some gaps. And then in that case, we need to figure out how we will fill the gaps. I'll give some examples of the gaps we found. Then after that, we will create the India relevant standards over here. So that will be the existing standards plus whatever we feel is necessary to the gaps. Then after that, the standards are no use unless you can test them. So otherwise anyone can say they're compliant to the standards. So we have to define some test cases, which we would do. And then after that, submit these recommendations to the DoT and we'll be done. So we'll be done in the first phase, because we are right now saying that today smart cities are useful. Tomorrow something else may be useful. So then the standards have to necessarily evolve. So here's an example of a use case. It's called Chotu AI, and done by a gentleman who has expertise in this area. So all our use cases come from users, governments, departments, or anybody else. So I haven't made up any of these use cases because I think this is important, just because I think it's important. So Chotu stands for Child Holistic Transformation Using AI. So the idea is that children in rural areas, they may not have good advice on parenting. For example, if you take a look, they may not have good advice on nutrition, for example, or things like that. So we'll have an edge cloud. The edge cloud consists of it's continuously capturing personal data about the child. Say, for example, generally what food the child eats, their weight, and so on and so forth. Then we have AI apps running in the cloud, which can access this data and then give some recommendation. For example, the AI app may look at the child's weight and the food they're eating and say, okay, they're malnourished and they need to do this or that or whatever it is. So that's an example. And they could also look at the way the child is doing studies and other things. So the idea is to supplement the caretaker's view with some AI machinery. So let's take a look at what storage standards we need to support this. And I think you'll find that it's surprisingly complicated. So simplest is data access. Even in data access, we suffer from the fact that if I took a look at, say, Amazon S3 and OpenStack Swift, the data model is different because OpenStack Swift has containers, an account container which contains information about the account to which the container and the object belongs, whereas that's not there in Amazon. So that's one lacuna. And the API definitions are also quite different for S3 and Swift. So right now, S3 is kind of like the de facto standard. So you might go with saying that object storage access has to be through S3 APIs. But as you can imagine, that is not enough. So there's a lot of other things like service level agreements, backup, restore, compliance, security, flexibility. How do you handle all of these? So compliance and security are obviously very important things because those are directly related to privacy. So here are some examples of what we need. So obviously data at rest, I need encryption, AES and RSA. I need secure protocols, so I need TLS 1.2 or higher. I need to be able to transfer data efficiently between different clouds. And SNIA has the linear tape file system standard, which is very useful for bulk transfer of data. And then many of the people, as you said, in India, they access stuff through mobile devices. So we need mobile device standards. And it turns out that there's something called the ISO IEC JTC 1/SC38, which specifies mobile device support for clouds. So we need to have adherence to that. Then I won't go through all of these, but there's network functional virtualization. Now, some of you may be surprised and saying, why do I need network function virtualization if I'm talking about storage? And the reason is that most storage nowadays, as you know, is network storage. So obviously, and many operators use network function virtualization to isolate different flows in the network. So if you really want security, storage security, you need network function virtualization, which is specified by a different standard. And then finally, when we talk about policies like who can access the data, etc., I need a policy definition, and there's a standard from IETF called SUPA, which I forget what that acronym stands for, which talks about policy specifications. So these are existing standards you can leverage. There are some examples of gaps in the standard. If you take a look at network function virtualization, one of the problems in the gap in network function virtualization spec as it is today is that I cannot find the security level information of a cloud. So that obviously is a big loophole, because if I want to transfer data across clouds, or if I want to start a workflow in a different cloud, and I don't have any information about its security level, then that is a constraint. So that's one problem. Then another example of a management gap is that the network function virtualization specs talks about how you can start processes, but that doesn't include edge devices. That edge device does not occur a specific category in that. And the question is, should something different be done for that? So these are some examples of the gaps that we have. So I think that's what it is. So this is the kind of work we're doing. If you are interested, please feel free and participate and join us. So here is some more cartoons about standards and cloud computing. So if there are any questions, I'd be happy to take them. Yes. So the way you would achieve that is we put down a standard, and then if you take a look at, say, OpenStack, that's a private cloud mostly, and Azure is a public cloud. So we would insist that the clouds kind of conform to these standards. Yeah, so that's why we have the test suite. So actually, what I said in the definition of the test suite is that it will be looking at degrees of compliance. So it's not like a binary thing that yes, you're compliant, no, you're not compliant. So there'll be a degree of, so each version will have a degree of compliance. Okay, thanks very much.